Hi, my name is Toshit Kirk, and today we are going to discuss how quantum computers are going to change the world. So let's start the video. So you must have seen these headlines across the internet. Before diving into exactly how it works, let's first see how the calculations and the data work in the classical computer. So basically, normal computers work on bits like 0 and 1. Everything from your photos to your videos is made up of 0 and 1. To understand it better, here is an example. For example, if you press the button A on your keyboard, it is converted into binary, then again into the alphabet to send to the display by the operating system. The best way to explain quantum mechanics is the famous thought experiment, Schrödinger's cat. Imagine a cat being placed in a sealed box with a poison, a hammer, and a radioactive atom, also a radiation detector. We don't know if the atom will decay or not. If the radiation detector detects the radiation, indicating that the atom has decayed, it releases the hammer and breaks the poison, which leads to killing the cat. If no radiation is detected, the poison stays intact and the cat is not killed. Quantum mechanics tells us that until we open that box, the radioactive atom is in a superposition state, like it is not decayed and decayed at the same time. And as the fate of the cat depends on this radioactive atom, that means cat is also alive and dead at the very same time. Similarly, quantum computers work on qubits. Basically, qubits can be 0 and 1 at the same time. For example, if you take two qubits, they can be 0 1, 1 1, 1 0 and 0 0 at the same time. Thanks to superposition, this helps computers to do a lot of calculations at the same time. Like in the classical computers, the value is always static. Like if you have two bits, they can be either 0 0, 0 1, 1 1 and 0 0. But with qubits, they can have all those values at the very same time. To make it even more easier to understand, let's imagine a database with 4 rows containing 2 bits each, 0 1, 1 0, 0 0 and 1 1. Let's say you have to find the last one, 1 1. What will the classical computer do is, it will compare 1 1 with other values, like it will compare it with 0 1, it will compare it with 0 0, it will compare it with 1 0, and at last it will find our value 1 1. But with qubit, as it is all of those numbers at the very same time, we will just use an algorithm, for example Grover's algorithm, to instantly get the result 1 1 using quantum gate. The current issue we are facing in quantum computing because of this is that we can only increase the probability of getting our desired number, like in this case 11, but we cannot say for certain that we will get that result. So that's why scientists are doing research on it from decades. Another important thing is entanglement. Like if there are two entangled qubit, they will have the same value at the same time. Like if one qubit is 0, the other qubit will also be 0, no matter the distance between them, also instantly. This makes it even more easier to do complicated calculations. Basically, quantum computers work totally different than the normal computers. Like it is not going to replace your classical computers for everyday tasks. It is for solving complicated problems. Here is how we can use quantum computers to make the world a better place and change the world forever. Quantum computers can simulate nature because essentially our real world is also a quantum universe. So basically it's not possible to simulate it with our classical computers, but with quantum computers we will be able to do that. It can help with the climate change, and scientists can find ways to mitigate them instead of testing those things in the real world. It can help with finding the theory of everything in physics. Basically right now we have a lot of theories in physics, but if we put them all together, they do not make sense. Like if we use only one theory, we can go to moon, like the theory of relativity, but if we put it with other theories, it does not make sense. So scientists are from decades trying to find a theory which will make sense put together. Other great use is cryptography. Quantum computers can break current encryption method that secure online transactions and communication. For example, it will be able to break the RSA encryption within hours, which are used by most of the banks, and classical computers can take decades for that. This will lead to the development of new quantum safe encryption methods to make data and interactions safe online. Quantum computers can simulate molecular and chemical structures much more efficiently than classical computers. This could accelerate the development of new drugs and treatments, potentially revolutionizing healthcare by curing diseases like cancer. Quantum computers can solve complex optimization problems in logistics, finance, and manufacturing more efficiently than classical computers. This could lead to more efficient supply chains, financial models, and production processes. Artificial intelligence and machine learning. Quantum computers can enhance machine learning by processing large datasets and complex models faster. This could lead to more advanced and capable AI systems. Quantum computers can help design new materials with specific properties by simulating quantum interactions. This could lead to breakthroughs in energy storage, electronics, and more. Quantum computers can perform complex finance simulation and risk assessments more efficiently, potentially transforming the finance industry by improving investment strategies and risk management. So these were some of the ways quantum computers can change the world. Let's talk about current challenges we are facing to get there. Error rate and noise. Basically, qubits are very sensitive to their environment. Tiny disturbances like temperature changes or electromagnetic interfaces can cause errors known as quantum noise. Keeping qubits stable for long enough to do complicated calculations is a huge challenge. Decoherence. Qubits can lose their quantum state due to the interactions with the environment, a phenomena called decoherence. Once decoherence happens, making it hard to maintain accurate computation. Scaling. While we can create a lot of small quantum computers, scaling up to a large number of qubits is hard. The more qubits we have, the harder it becomes to maintain the error rate and the complexities of the system. Quantum error correction. Classical computers have effective error correction methods, but in quantum computing, correcting errors without disrupting quantum states is very hard. Developing quantum error correction codes is an ongoing challenge scientists are working on. Manufacturing. Building reliable large-scale quantum processors is very hard and expensive. The materials and methods used to create stable qubits are not yet perfected. Algorithm development. Quantum algorithms are still in their early stage, and only some algorithms have worked and understood so far. So we need more breakthroughs in quantum algorithms to use the full power of quantum computers. Energy consumption. Some quantum computers need to be cooled down to absolute zero, which requires a lot of energy and sophisticated cooling systems, which leads to a lot of cost. So these are the challenges that we are facing in quantum computing as of now, and we will have to overcome them to get all the benefits we discussed about earlier. I think it's a very great technology and I'm very optimistic about it. Let's see how it goes. Hopefully this video was helpful for you to understand quantum mechanics and quantum computing. If you have any questions, you can let me know in the comments below. This is just the beginning. Stay tuned to see how quantum computers will change the future of our world. I will see you in my next video. Again, thank you for watching this video.